Hello, everyone. Let me start by saying thank you for Codementor for organizing this event, especially to Darren for inviting me and to prepare everything. And of course, I also want to thank you, that's the other side of the screen, taking the time to assist to my talk. I hope everyone is safe and secure. This Butter tool is really great. It allows me to see what you're saying in real time, which is great if you want to make a question. And it also allows me to interact a bit more close to you. For instance, I'm going to create here a poll, just wondering how long have you been an Android developer? So feel free to answer to this question so I can have a better idea and to know who's on the other side of the screen. Nice, an iOS developer. So, welcome to this composable new world. As Aaron pointed out, I'm an Android GDE. I'm also been organizing events here in Portugal at GDE Coimbra. I've been writing at Render League. I have this dream of one day having my own podcasts, or at least co-host one. So, if you have the same passion, please talk with me afterwards. I love to travel, photography, and running. I've created a set of materials for this talk. You can see the slides at my speaker them. I'm going to tweet everything and share the links here on Butter at the end. I've also created an application with Compose, not only for Android. So if you want to know what this means, stay until the end. I've created a code lab. So you have a workshop that you can follow step by step also on my GitHub. And I'm trying to be a YouTuber and I'm launching a set of videos focused on Compose, so feel free to subscribe my channel. So a brief history of Android. So Android started a long time ago in a galaxy far away. And let me just look at the poll here. And I'm seeing that we have a lot of people interested in Android. And I have a new one just ready for you. That is, are you working with Jetpack Compose? So Android started somewhere around 2008, and we've seen a lot of development since then. Okay, nice. People that want to start, it's what I wanted to read to see. So it started way in 2007, and we've seen a lot of great things since then. We've moved from Eclipse to Android Studio. We moved from list views to circular views. We had the constraint layout that allowed us to build better and more appealing applications. We have the Arc components, the Kotlin, which was a huge step towards better Android development and what we call the golden years of Android development that just got better when we moved to Jetpack Compose last year. So Jetpack Compose was stable last year, and we've been seeing new versions since then. We're currently on the latest stable version is the 1.0.5 that supports Kotlin 1.5.31, but there is already in the pipeline to be launched in the upcoming weeks or months the Jetpack Compose version 1.1.0 that supports Kotlin 1.6.0 and also the 1.2.0 that supports Kotlin 1.6.10. This is important because at this moment, Compose is still strictly linked to the Kotlin version that you're using. So it's great that Google is trying to use the latest versions of Kotlin so you can just update everything and have the latest version of everything. So I'm guessing that you're all right like me, really excited about Compose. So let's start by understanding what's Compose. So the first time I heard about Compose, I decided to look what Compose is. And if you go to the dictionary, we're going to see something like this: to write or create a work of art, especially music or poetry. And I'm sure that we now need to update this and beautiful design UIs, because this is what Compose allows you. It allows you to create UIs so easily. And if we open now the web page for Jetpack Compose, you're going to see a lot of keywords like less code, intuitive, faster development, powerful. And this is exactly true. I've been playing with Compose since last year, since January. I already have apps on Compose, and it really fastened my app development. It allowed me to animations so easy to do with Compose. It's not more those motion events that you need to take care of. It's really simple to do it with Compose, and Seriously, you have that initial learning curve, but in the end, after a couple 1 2 months, you're going to write applications way faster. We can grab all of these keywords and have them on a slide. And it's important to mention that Compose it's unbundled from the operating system, meaning that, for instance, there was a feature that was launched on Android 12. So typically you could only use it on Android 12. Compose allows you to use it on a lower version. You don't need support libraries, you don't need anything, you just need to use Compose. It's open source, it's intuitive, it means smaller APKs. It uses Kotlin, it's a modern framework, and there is a special keyword here called Declarative UI. There is a paradigm shift of what we're already used to. So let's talk a bit before we dive in about Declarative UI, and let's create a battle here with Imperative UI. Imperative UI is currently what you're using with XML. Declarative UI is the future, let's call it. Imagine that you want to create a list on an application. Most applications have lists, so this is something that from one time or the other you already need to create one. So typically what happens here is you create an activity, you then create the corresponding XML for that activity, you then create a fragment, you then create XML for that fragment, you then create a recycler view, you then create the adapter, and then finally you create at least one XML or multiple XMLs if you have different items that you want to show. So if you look at these numbers, this means that at least you've created 5 files and you've written more than 200 lines of code. Between declarations, XML attributes, you spent quite some time trying to do something as simple and that almost all applications have, that is a list. So this means that you're going to take some time, more time that you could spend doing some new cool things, and you're just reinventing everything. It's error prone. If you're writing 200 lines of code, the probability of adding an error, it's common. We've all had something because we forgot something on our view holder, because the on click on the adapter wasn't in the right place. It happens. You end up creating more files, more XML files for your views. So this means that you're going to have a bigger APK, and you have a couple of components. What I'm saying about where should the one-click be, this is a huge question, and people have different answers. If it should be on the adapter, if it should be on the fragment or the activity. So there is no common sense where something should be something that all lists or most of all lists use. And of course, not only on lists, but for instance, imagine that you want to change the state of a view. For instance, we have hello world here, and we want to say hello Android world. This is a really pretty story, let's say, because these change almost yearly, and you can do things differently. So a brief history how to change the access and change the state of a view. In the beginning, on the dark ages, if you want to access a view, let's say that its ID was tv_greetings, you need to call text view and find view by ID. Then you cast it to text view. This is a really long sentence that you need to type just to access a view and update its value. So after a couple of years, you had a library created by jQuarton called Butterknife that you just needed to use an annotation. And basically, you could use greetings everywhere. The downside of this is your compilation time increased a bit. So after a few years, Google decided that, okay, it's no longer need to cast to text view, calling find view by ID, it's enough. So you just need to do something like this. And then with Kotlin, we were introduced the concept of synthetics, and you don't need to do anything. You just need to import your activity and then call your ID from there. This was get deprecated, and there is something that we're currently using, those that still program with XML, that it's the view bindings. Basically, we inflate a binder for that view, and you can access quite easily by calling binding and then the ID of the view that you created without underscores. So if you look at the base concept of all of these components, it's called the view.java. And then if you look at text view, at image view, it's also going to extend view.java, and view group, for instance, the linear layout, it's going to extend view.java, and of course, linear layout extends view group that extends view.java, the relative layout extends view group that extends view.java. So almost all components that are related with UI are going to extend view.java. And the number of lines that view.java has is, yeah, this is quite big. Now imagine being the, I'm going to call it poor developer that needs to maintain view.java, knowing that any change on this class, it's going to affect everything. Everything that it's doing is going to affect images, text views, linear layouts, all of those components. So the pressure is really, really high. This is really difficult to maintain. And in the end, you're bundled with the device implementation of these components. You're bundled with the version of the Android version of when these components were launched, and you can't do anything here. So the goal of Compose is to solve this, along with a modern UI and a really cool language, and to unbundle from platform releases to allow you to faster develop everything and clarify a bit the state of ownership and who should handle finally that on-click event. So on the one end, we have the imperative UI that use Java or Kotlin code, and you've got XML with attributes, styles, layouts, everything. And the other side, you have declarative UI with UI as a function and Kotlin code. I'm seeing a question here. Yes, you can combine your existing XML code with Compose, no problem. Uh, if you have a big project, this is my advice. Don't try to rewrite everything from the start. You can do it, start small, and just you're going to develop a new feature, and you can do that feature only in Compose. So if we have imperative UI and declarative UI, we can see imperative UI as more of how things should happen, and declarative UI on what should happen. Let's see a really simple example. Imagine that we want to build this image depending on the number of emails that we have per read, so the number of unread emails that we've got here. So if we're going to follow this approach in an imperative UI way, so using the XMLs, and don't be extremely careful with this code, this is more of pseudo code. But basically what we do is something like this. So if the count is bigger than 0 and you don't have a badge, you add a badge. If the count is 0 and you do have a badge, you remove that badge. Now, next iteration. If the count is bigger than 99 and you don't have fire, you add fire and set the text as 99 plus. If the count is less than 99 do have fire, you remove the fire. If the count is bigger than 0 and you don't have a paper, you add a paper. If the count is equal to 0 and you do have a paper, you remove that paper. If the count is less than 99, you set the badge as the number that's currently there. So you're writing a lot of code just for something that is really, really, really simple. Now, let's see how we can do this on imperative UI, on declarative UI. Exactly. It's this simple. Basically, you're going to have 6 lines of code, and I'm counting the closing brackets for this. And you're going to use the annotation at composable because it's a composable function, but you just need to write this. You're going to show an envelope if the count is more than 99. You're going to show the fire if the count is bigger than 99. You're going to show the paper if count is bigger than 0, and if count is bigger than 0, the text should display count. It's as this easy. And if there is any change on the count, this function will just call itself once again, and you have the guarantee that you're going to have always the latest version. You don't need to be adding and removing stuff. Every time there is a change, the function will redesign. So we have a clear winner here. I'm hoping that you all agree with me. That's the declarative UI. So let's dive a bit more about Compose. So the first time I look at Compose, this tweet caught my attention because Jake Wharton was saying that he was playing with Compose on iOS, and I was immediately, what? But this is Android. How the hell are you playing with this with iOS? And then, of course, a lot of people were joking about this. And this is exactly true. You can have Compose on more than one platform. So if you look at the Compose libraries, This is basically what Google has on their own site. They say that the Compose is composed with compiler, runtime, UI, foundation material, and animation. And we can group them into a stack to be easily to understand. And we can have the UI, foundation material, and animation into what we can call of Compose UI toolkit. And then we have the Compose compiler and runtime on the bottom. But let's look first at this Compose compiler. Basically, the compiler transforms the composable functions that add composable that you saw before into something that is going to be rendered. So it doesn't use the notation processor, meaning that this is really, really fast and it doesn't impact your build times. And basically, it's going to build at the system level, at the code generation level. You're going to have to be translating your composables to real UI. The runtime is built on top of the compiler, and in its essence, it's a tree management solution. There are people using the Compose runtime and compiler without having UI on their side projects. So this is possible. It doesn't know what Android is or what UI also is. And then we now move to all the libraries that are part of the Compose UI toolkit and what we use to interact and build your UIs. For instance, you've got the Compose animation that allows you to create those beautiful animations a bit outside of the box, the material that allows you to have a material design system and easily create your design system without needing to override attributes that you don't know where the hell they are, and you need to be looking at widgets to understand what you need to change. The foundation that allows you to create image, text, everything, and the Compose UI that allows you to see what the user is typing, for instance, on the keyboard. So on the left, we've got the runtime and the compiler, and on the right, we have actual projects that are currently using Compose: Android, desktop, web, console, Raspberry Pi, and even there is a small leak that's supposedly JetBrains is working on iOS. So I noticed that there were iOS developers out there. I think you're really, really be interested in Compose. This means that Compose is multi-platform, it's already stable, it's already there. You can use it as stable version on web and desktop. So I bet that the first question that everyone is doing is, should I switch to Compose? A lot of applications are already using Compose. This doesn't mean that they are using Compose everywhere. This means that they have screens that were built with Compose. So once again, the question that I had previously, yes, you can use Compose on some screens of your app. You don't need to redesign everything. Some cool statistics. There is an app that was created by Chris Bain. It's called TV. And basically just shows the TV series and movies that are out there. And he migrated his app to Compose. These were the values that he noticed before and after. So the APK size were reduced in 48%. The method count was reduced in 41%. So the number of lines of code decreased a lot. And in the end, the build speed also decreased 26%. So should I switch to Compose? Yes. Since we're talking about Compose, one of the things that I need to mention is the company's library. Basically, all of those features that you need to implement, like view pagers, swipe to refresh, all of this is already given for you from granted. You just need to call a function and you have everything there. And the great thing here is that, once again, this is not coupled with the OS. So for instance, imagine that you want to use the latest keyboard animations from Android 12. Yeah, you can still use it on Android 10 or Android 9. You can still use them because you're not bundled to the OS. How to start? This is quite simple. If you want to start a project from scratch, you can just call and create a new empty Compose activity. If not, you just need to say that your minimum SDK version is the 21. So Compose works on 21 and afterward. And then you enable the build features for Compose. And you define the Compose options to say which is the Compose version that you're using. So 1.0.5 at this moment. And the Compose and the Kotlin compiler version that you should use. If you then want to add the the libraries are a bit different. They are inside the Compose namespace. So instead of adding androidx.appcompact.ui, you need to have androidx.compose.ui. And let's see a simple example before and after, let's say, of how we typically do things without Compose and how we're doing things with Compose. So I'm seeing that we have a couple of questions here. Let me just see. So where there are situations you might want to use regular XML over Compose. To be honest, yes, there might. How can I rephrase this? Last year, yes. For instance, I was trying to use the camera activity. I wanted to take a picture with the camera, and I want to build my own camera. And at that moment, doing that with Compose was a bit difficult at the time, or at least I didn't have the time to implement it directly. So I basically ended up using for that specific view the camera activity with XML that I was already familiar with. At this moment, you can still at this moment you can now use it the Compose view, and you don't need to use XML for this. Since XML exists for the past, I'm going to say 10 years, I'm assuming that there might be one or another case where you might need to reuse something that it's built on XML. There is no problem. The good thing here is that as time goes by, you start to have those libraries with Compose, and the number of times that you need to use XML are way lower. For the past 6 months, I think I've never needed to use XML, and I've built two applications. One of them was a bit complex without any major issues. As Compose Runtime is a tree management solution, is something like a defining engine with a virtual DOM similar to React.js in the sense that it does the runtime work. I'm not entirely certain how React.js works, but I think the answer is yes. So it's basically something that exists underneath and is capable to convert these objects into the mappings that you're giving on the UI. So imagine you need to define how things should be built. How can I explain? So basically, this is going to be a tree of nodes that the UI is going to use to be built, and you just need to define what they mean on the Compose UI toolkit, so the runtime knows how to translate things then to the UI toolkit. I'm not sure if I explained it right. In any case, I can revisit this question if you have any more questions at the end, Admo. So getting back to the slides. So imagine that you want to show a simple message, hello world. Typically, without Compose, you will do something like this. You have a text view, and then you have the text. And if you want to change this text, you're going to just call find view by ID or use the view bindings, and then access the text property or function, and you're going to call it to say hello and write, and that's it. If you want to do this with Compose, we just call one function. Okay, we have one function, and you say what you want to show. If you want to update this value somehow, you can just create a composable function, and it's going to receive a parameter that you're going to use to build that function. So it's going to be something like this. You need to use the composable annotation. This means that this is going to be inside the Compose. You define the function name as you typically do with Kotlin. It's the same syntax. And then in this case, you receive the parameter that you're going to use on the text. This text, it's a composable function. So basically, it's another thing like this, but instead of calling greeting, it's called text, and that you can use to draw text. So now imagine that you want to have two texts, one after the other. Typically, without Compose, you do something like this. You have a linear layout or a relative layout, depends what you want to use. You have two text views. If you want to do this with Compose, you add your function and you can add another one, right? No. So basically, when you call the functions, it's the same thing that happened before. It's going to be drawn on the top left corner. So calling the several functions, text, image, over and over again, it's going to always appear on the same side. So basically, you're going to use what we called a view group with XML, and in this case, it's called column. Basically, column allows you to stack things one after the other. In this case, a column allows you to do it vertically, but of course, you can also, instead of calling column, you can call a row, and you're going to do things horizontally. No problem. You don't need to play with orientation, horizontal, vertical. No, you call different functions. It's easier to understand what they're doing. Now imagine that you want to define a background, and you just need to call a modifier and then the background. Basically, modifier has a large set of attributes that you can use to define different things. For instance, I'm going to define the background as green. I want the background to be on the entire screen. I'm going to say that this column, it's going to fill the entire screen. Now imagine that I want to add a padding, for instance. I'm going to call padding and say that I want 16 dps. But I'm not happy. We have such a big screen, so let's put all of this text in the center. Okay, no problem. You can call horizontal alignment and vertical alignment and say that you want things on the center. And that's it. Now imagine that we're all designers and we're not happy with it being black. You can just call text color and you call it white and it's immediately white. Now imagine that you want to show an image. Without Compose, we'd call image view with source or background. You're never quite sure which one you should call. And then you need to set the width and height and everything. With Compose, you call the image function. This is great. Yeah, no need to play with match parent. It's quite direct. You call the image function, you define a content description, and it's important to define a content description because this is for accessibility. So this means that if you have accessibility mode on, it's going to say what that image really is. Once this is done, you just need to call image and you've got automatically your image on the screen. If you want to add a button, if you want to do this before Compose exists in XML, you would call the button function. Once again, that bloody wrap content that you never liked and the text. With Compose, it's quite simple. You call the function button. And then if you want to add a text, you add a text function. So basically, you don't need to override a lot of attributes. You can just call those functions inside button. Now imagine that, number of coffees. I have already had one today. So I want to increase this value from 0 to 1. So before Compose, you need to create a set on click list and on the button itself. And then every time the button increased 1, you need to have a variable that you're going to update and then set on your text that value was updated. With Compose, you just need to do something really simple. So on click, you're going to increment the value. A cool thing about Compose, once again, is that you don't need to call other things just to say, oh, I updated this value, please update. No. With Compose, basically, this function is going to redesign on every change that exists. This is why we have a remember here. This remember function remembers the value that you've defined and that you've updated on every iteration that this function has. For instance, in the initial value, it's going to be 0, so it's int 0. The next, when I click on click, this value is going to be 1. When I click on the button and update this value, this function itself is going to be called again. But since I remember the initial value, so it's going to redesign itself with 1. And I know that this might sound strange, recalling a function, it's going to be a bit of work and it's going to be heavy. No, this is completely simple and it doesn't impact anything. Also, don't forget that the entire UI it's rewritten every 16 milliseconds, depending on your screen refresh time. So this is something that already happens. Now, remember that previous example on how to implement a list? Yeah, I need to create a lot of things, compose, XML, fragments, all of this. Yeah. A lot of time consuming, a lot of text, all of these that you were doing before. With Compose, it's so simple that you just call list view. You call lazy column, and you automatically have everything for you. All that list can be resumed in 5 lines of code. Quite direct. So I've been talking about Compose. I just want to show you a couple of samples. These were from January. Basically, there was an Android Dev Challenge, and people are just playing with Compose. remember, this was the beginning, and during this Android Dev Challenge, people in less than a week were able to build this without big knowledge about Compose and without all samples that we currently have on Compose. It's also worth talking about that I've built an application that you can see on my GitHub that basically it's a really simple application. It communicates with the Unsplash API to get the latest images, a couple of images from Portugal. You can enter text on a text field. You can move from one screen to the other. All of this is built with Compose. And since I have this already built in Compose, I basically, using this Compose code, I called a different function and immediately have this code running on my watch. So it's part of the same code. I just need to call a different, what we call scaffold, and I was able to run it on the watch. And now that exact same code that I had on Android app, I was able to compile it for desktop. And I have a desktop app that looks the same, but it's running on the desktop. The number of lines of code that I needed to write was almost zero. I need only to care about what you're going to see now, the Windows implementation, and to be able to resize the window. And once I had this, I was able then to move to the web. The web, it's not as direct as one might think, because what I could reuse was smaller, basically because it's still on its early stages, although this is a web page running code that was built using Compose. But for instance, as you're using images, text, and columns, you still need to use, for instance, the DOM elements that were mentioned in the previous question. You still need to use them for the web. You still need to use, for instance, divs and the flags and all of it. Couple of resources that are worth mentioning. So you're not familiar with Compose, you want to implement, for instance, a recycler view. So yeah, you can go to this page, what the equivalent of X in Jetpack Compose is. You write there recycler view, and you automatically going to see that it's lazy column. So just enter what you want to search, and automatically you're going to see what's the equivalent on Compose. A couple of resources worth talking about. So we've got a lot of Compose samples. You have a curated list of projects on Google's GitHub, on JetBrains GitHub. We have a really strong community. IntelliJable, it's Leland, it's creating live Twitches, is from Google in this developing an application from time to time and explaining how things work underneath. You've got Joe Birch that also launched the book recently that only focuses on Jetpack Compose. George Castillo also has a book, and it's really, really good. So there are a lot of things that allow you to now just dive in Compose and welcome this composable new world.
Awesome. Well, thanks so much, Carlos. I'm not an Android developer myself, but just by looking at the examples, I mean, it seemed pretty magical to me. I was sharing on Twitter that the only mobile development experience I had was I took an iOS class in college, and we made a Flappy Bird game. It was, I just wonder what it would be like to write that in Compose, because I took that class like 10 years ago. But anyways,
yeah. To be honest, I'm just waiting for Compose and to have a bit of free time to play with Compose for iOS, because for me that is going to be great.
Yeah.
Although Swift UI and Compose are a bit similar in syntax, I really want to see how that goes and how Apple is going to react to it.
Yeah, I bet. All right, so yeah, we have a little bit more time, so we have this open up the floor for you all to ask questions. So yeah, feel free to type in the chat, or if it's something pretty complicated and you'd rather explain out loud, then you can also use the Q feature on the left. All right, so yeah. Oh, actually, yeah, I think Somesh asked the question. I don't think it was answered in your talk yet, but they asked, why alignment and arrangement? Is there anything significant to it?
Yes. So basically, yes and no. Basically, one is used when you want to do something horizontally, and the other is when you want to do something vertically. So if let's see if I'm able to say this right. If you're using a column, it's a horizontal alignment. If you're using a row, it's going to be a vertical alignment. So you use one if you're using a column, you use the other if you're using a row.
Okay.
If you want to start to learn Compose, do you have a course that you recommend? To be honest, I think one of the best courses out there, it's free, it's from Google. If you go to Google Code Labs, I think even if you now go to the Compose main page, you're going to have a couple of links there saying starting with Compose. And basically, it's a bit similar what I talked on the beginning, where I've created the Code Lab. So Google created a couple of Code Labs that are really, really good. And you can follow step by step, seeing the text, seeing the final project. And it allows you to understand some of the concepts that are a bit difficult to understand at the beginning. For instance, I know that when you talk about declarative UI, at least for me, it was a new concept. I know that from people that from web, they are already a bit familiar with it, but for mobile developer, it's something new, and they explain in detail how things should happen, why the function is going to redesign itself, how can you access specific values, something like that. Short answer, the code labs from Google are more than enough to start. And they also have the sample projects that are more complex applications that you can also see how they're doing specific behaviors. So
Okay.
what advice would you give to upcoming Android dev to learn Compose or XML? Well, on my opinion, if you're starting something new, my advice is always to learn Compose first, because it's where the industry is moving to. But of course, this depends a bit on the company where you work or where you want to work, because we cannot forget that we have, I'm going to say, 10 years of applications developed using XML. So if you're going to work on a company and you're not going to start a project from scratch, the probability of working with XML, it's pretty large. Being said, on my opinion, you should start with Compose, but remember that if you're going to work for a company, most certainly they're going to ask you something on XML. Are custom views easier to do with Compose? Yeah, way easier. Yeah. Not even comparable. You just need to call functions and things work. And they are more easier to debug and to understand what's wrong.
Okay.
So Jetpack Compose for iOS, do you think that Android developers might use Jetpack Compose to write UI for iOS without knowing iOS? This is, for instance, let me tell you my story. I've programmed for iOS a while back, and I'm familiar with Swift UI because I want to show the power of, for instance, for multi-platform. And you need to know the basic concepts of iOS. For instance, imagine that you have the one create on Android, so you need to know the equivalent on iOS. An application lifecycle, it's a bit different. You need to know both things. You need to know how to call a function. On Android, you've got, for instance, the shared preferences. On iOS, you have the NS user default. So you still need to know how to interact with the API. But this allows you to reduce that initial learning curve, where you need to learn an entire syntax from scratch. You already know it. So the big advantage for Compose for me is that if I want to do something on another platform, I don't need to learn an entire language or an entire syntax behind it. I can just reuse what I already know with Compose, and I've been using daily with Compose. Once again, I'm not sure how Apple is going to react to this. So this is still an experimental project on an iOS. So let's see how it evolves.
Right. Yeah. Do we have any more questions? Maybe have like time for one more if there is somebody with questions. But if not, it's all good. Okay. Yeah. Thank you, Carlos, for answering those questions. I just want to make a quick announcement. Since we're talking about Android today, there's another event coming up that might be interesting to you. I'm going to put that in the chat right now, along with some other helpful links. Yeah, and I'm gonna show it at the end as well. So yeah, the next event that we have that you might be interested in is called Functional Programming in Kotlin. It's happening in about 2 weeks. So the speaker, his name is Raymond. He's a senior software engineer who specializes in Android. So I really believe it's going to be quite informative. Yeah, and that's not the only event that's happening, of course. More and more events are happening because now we have community members like you all who are hosting their own events. So yeah, check out our event page for more. Right now, yeah, I want to take some time to thank you, Carlos, again for sharing your experience, sharing your passion for Jetpack Compose.
It was a pleasure.
Yeah, is there anything, any final thought or encouragement that you would like to share with our audience before we move on?
Yes, I know that when you try to learn something new, and if you already know XML, you might feel that, okay, I already know how to do views. Why do I need to learn it again? And I know that the couple of weeks or months you might feel a bit challenged because you're relearning, let's say, how to build UIs. But in the end, it's where the industry is shifting to, and it's worth it. You might not see it on the first weeks because you're going to take more time to do something simple. But after a couple of months, you're going to see that investment is paying out and you're building applications way faster than you were doing before. So don't worry if it's going to take you 1 or 2 months. With me, it took way more than that time. But at this moment, it was the best decision I did. And my managers are happy with that decision. So they could see the advantages of Compose.
Yeah, great advice. All right, thank you so much, Carlos, and also thank you so much all for joining. I'm going to put the information up for the next event. Yeah, and I'll just keep this session open for like a minute or two, just in case you want to get the information.